All right, so I'd like to talk a little bit about clock ring and the electrical isolation responsibility of the CPLD. One of the first things that I noticed when trying to string several IMUs in a line sharing the same bus is that I was likely to get things like clock ring, especially because of the fact that these things are going through several different connectors and trying to daisy chain 17 of those IMUs on 1, 2, 3, 4, 5 PCBs in a row in the worst case, and then have a 5-way star. It was too much. There was no way that clock integrity, even down to 5 megahertz, was going to be reliable. So I spec'd a 10 megahertz oscillator for the CPLD, it's going to be the root oscillator for the whole CPLD. But in this case, it's relevant because 10 megahertz is the top SPI bandwidth of the IMUs. So it might even get to the point where the CPLD has enough space in it, and it's looking more and more like this is going to be the case, that we can manage to get stuff like automatic IRQ retrieval for exact causes of when an IRQ pin goes up, and not involve the host until we have the answer, thereby saving bandwidth and latency. So that's certainly possible. At that point, we might decide to scrap the CPLD in favor of a proper FPGA, but it would increase the cost a lot, and so I went with what would be the minimum I felt with reasonable odds of expandability. So the longest electrical chain in this case, because of the CPLD, is 1 digit. So each digit is electrically isolated signals from everything else. The CPLD drives the clock, drives the data bus both directions, handles buffering and how it relates to the addressing, and drives the address pins to each digit as well. So if you disconnect 1 digit, or even in the worst case, short circuit all of the non-power pins on that digit, it won't affect the other digits. The software would be able to notice that the digit is no longer returning valid data and simply ignore it. So there's a lot of benefit to that design, considering how the thing is going to be used and worn. I don't know about anybody else, but I beat the hell out of my hands. So the thing has to be durable, and it therefore has to be a little more redundant. So the host SPI communication ends at the CPLD, so it has to traverse 1, 2 connectors, probably 2 vias, and then it's done. The sensor's max rate, as I said, is 10 megahertz. The CPLD I could drive much faster than that, but the bandwidth calculations that I did in the worksheet that's in GitHub, at about 150 kilobits per second, there's no more bandwidth required. I could do full register reads off of every IMU at their maximum update rates and not have to get more than half a megabit out of the bus. So it's not a whole lot of data, but it is getting it in a timely manner is important. So the IRQ aggregator, even though I can retrieve all of that information via an SPI bus read out of the CPLD, the pins are broken out so that we can get lower latency signals back from it and base it on when the IRQ signal gets raised in the program, already know ahead of time if it was a tap interrupt and which digit it was. So I have enough leftover pins to do that. I'm real pleased with how Quartus has handled my design. I've assigned all of the pins already, and I still have 79% of the CPLD area. I'm sorry, 69% available. So it only took up 31% of the area. Now, granted, that's no IRDA peripheral either, which we'll talk about later. But even having all of the pins hard specified, which is a big constraint with that compiler software, there's a whole lot of area after all of the addressing and timing and IMU selection code design has gone in. So I'm optimistic about that choice. That choice is going to give us the freedom to probably eliminate one of these 2 connectors. You can see that up here there's this connector these are the unpopulated boards, of course, but there's one 16 pin. I'm sorry, the 14 pins on the top, and then there's a 16 pin on the bottom. But both of those flex cables go to the metacarpals board, and I'm probably going to be able to eliminate one of them if everything turns out okay. So there's more design consolidation that can happen there. Next video, I'm going to talk a little bit about the IRDA peripheral, and that should be the last I have to say about the CPLD.